Hello and welcome to this tutorial from the Brick Development Association. We are the trade association for the UK clay brick industry, and without question the most common design query that we get is around movement in brickwork and what we need to do to our designs to allow for that movement within the brickwork. This tutorial, it is just an introduction to the subject, so all designs should be checked off with a structural engineer. And if you're looking for someone to start, then brick manufacturers are always willing to help. So let's start by having a look at why we get movement in brickwork. Well, we get movement for four main reasons: thermal movement, moisture movement, structural loading, and chemical changes. So it's the first two of those, thermal movement and moisture movement, that are particularly influential on masonry movement. Thermal movement, quite straightforward, just any changes in temperature within the brickwork, within the masonry, can lead to sort of cyclical expansions and contractions due to the temperature changes. Obviously impacted by things like how much sunlight the brickwork gets, whether that's direct sunlight, whether it's shaded. The second one that has a significant impact is moisture movement. And how saturated the brick is, that can lead to some cyclical movement as the brick gets saturated and dried out, but that can also lead to some irreversible long-term expansion. And brickwork, generally speaking, tends to expand over its lifetime. You will get the cyclical movement, but the general direction of movement is expansion. The other two factors are structural loading, so any sort of imposed loads, any loads transferred from roof trusses or floor beams which might be loaded onto the brickwork, that can have an impact on the movement. And then things like the dynamic loads like wind loading, snow loading, any sort of occupation within the building, that can have an impact on movement within the brickwork. And then finally, and much more rarely, chemical changes within the brick can cause movement. This picks up things like sulfate attack. But yes, those last two generally have a much smaller impact on the overall movement. Clay brickwork, like I say, is generally subject to long-term expansion, where concrete masonry, which is concrete blocks, aircrete blocks, they do the opposite. They tend to shrink over their lifetime. So if we don't allow for that movement within the brickwork, we can end up with a scenario like this. The movement can mean that there is a build-up of internal stresses within the brickwork, within the brick, within the mortar, and that can lead to cracking, whether it's through build-up of tensile forces, as you can see in the image on the left, or whether it's due to compression, as you can see in the image on the right. So to make sure that we don't end up with those unsightly cracks in the masonry, the solution is to introduce movement joints into the design to allow for that brickwork to move and expand into those joints and avoid those internal stresses building up in the brickwork. The golden rule for allowing for the movement is to introduce movement joints at maximum spacings of 12 meters. So as I mentioned, brickwork wants to expand over its lifetime, and it will expand by around 1 millimeter per meter length of brickwork. So you have those movement joints there to allow for the cyclical expansion and contraction, but you also have it there to allow for that long-term expansion. And if you think of that 1 millimeter per meter length of brickwork, if you're around that 12-meter spacing for your movement joints, then that movement joint width needs to be about 16 millimeters to allow for that 1 millimeter per meter expansion, plus around 30% for the compression of the mastic and the filler which are put within the movement joint. What a lot of designers like to do is keep that spacing down to around 8 meters. That allows you to keep the movement joint width around 10 millimeters, which means that it's then the same width as your normal bed joint or perpendicular joint. And then you colour match the mastic and you just don't read it as anything hugely different from the mortared joint between the bricks. In a straight run of brickwork, the maximum recommended spacing is 12 meters. When you have a corner in the brickwork, which you will for most buildings, the maximum recommended spacing from a corner is halved that to 6 meters. If you imagine in a straight run of brickwork, that brickwork can expand in either direction. When you introduce a corner, you effectively introduce a fixed point within that panel of brickwork. So the expansion is halved. So if you imagine if you have a corner, you're always within 6 meters of that corner. So you never have more than a 12-meter run of brickwork around a corner. Freestanding walls are a specific scenario for movement joint spacing. The maximum recommended spacing for freestanding walls is 6 meters. And the reason being is that they tend to be more exposed. You're obviously getting weathering from both sides, and they're unrestrained at the top. You have your foundation, which holds the brickwork in place at the bottom, but the top is effectively unrestrained. In addition to that, where you have your coping at the top, depending on what the material of the coping is, depending on what the fixing of the coping is, you may also need to reduce the spacing for movement joints in the coping, again by half to keep things simple, to 3 meters. If you have any doubts there, it's worth checking with the manufacturer of the coping just to see what the exact movement requirements are. For similar reason to freestanding walls, the maximum recommended spacing for parapets, where you have them on a building, is also limited to 6 meters. Where you have a parapet on the building, to avoid limiting yourself to 6 meters for the whole building, because as a rule, movement joint should normally extend for the full height of the panel of brickwork. What we say is that where you have a slip plane in there, so where you have your cavity tray in there at the level of the roof structure, where the parapet starts above, then the movement joint for the parapet can stop at that level, and that cavity tray will act as a slip plane, and you won't get the transfer of movement from the parapet into the panel below. And then you're sort of back to your normal 12 meter and 6 meter spacing from a corner for the panel below. And then similar to the freestanding walls, just check with the manufacturer of the coping to see whether there needs to be a further reduction in the spacing for the movement joints in the coping. Short returns are another specific scenario for brickwork. If you imagine you have 2 long panels of brickwork and they are joined together by what we call a short return, which is 675 mil or shorter of brickwork, which is effectively 3 bricks in stretcher bond. Those 2 longer panels are going to want to expand into that short return, and you tend to get a cracking in these corners, which you can see illustrated quite nicely in these images. You can see the short return and that crack forming down there. And you can also see on this image on the left, actually, you have the long panel here, you have a long panel on the other side, and you've had the crack sort of forming down that external angle. But actually, where you have a shorter panel of brickwork below, you're not getting that same degree of expansion into that short return, and that is why that crack has stopped at that level. Where you have a longer return joining 2 longer panels of brickwork, actually there's enough length within that return to accommodate that expansion into the area of brickwork which is joining those 2 panels together. This diagram is obviously exaggerated, but it illustrates what will happen with that scenario, and you don't get the tendency for the brickwork to crack in these locations. So the solution for short returns is just to debond one of those longer panels of brickwork from the short return. There's a couple of different ways of doing that. It can either be done with a compressible joint, so you debond the brickwork here, and that longer panel can move in this direction, and you will get the compression of the movement joint there, but that movement won't be transferred into this short return. The other option is the image on the right, which is a slide-by joint, which is probably less favoured because actually you probably tend to read that a bit more in this corner here. But again, that movement of the brickwork in this direction. It's not transferred into the short return. And if you imagine that as sort of, if this side is is inside of the building, actually when you're looking from the outside, that movement joint, you don't really read it as anything hugely different from your normal bonded corner. As you can see in this image here, the movement joint's been formed in the internal angle, and you can see the compressible filler sort of within this area. Actually, when the mastic has been applied, you colour match that mastic to the mortar colour, and you just don't really read it as anything hugely different from your normal bonded corner. So I'm just going to take you through an exercise very quickly, just to give you a sort of a rough understanding of how you would approach setting out your movement joints. Then I've got a plan of a reasonably large building here, just to make sure that we will require some movement joints. This is obviously just the plan. To fully understand the detail, you would need to work with the elevations. You know, you can see the openings at this level, but actually, are there panels of brickwork above those openings? Is the entrance, does that continue all the way up, the sort of the recess for the opening, or does that just stop at ground floor and you have a different scenario at the second floor or the spandrel zone sort of in between those floors? So for the sake of argument, you know, we can't see the detailed dimensions on here, but we'll run through it and you should hopefully just get a rough understanding of how to approach the setting out of movement joints. So I'm going to start in this corner here, and I'm going to work clockwise around the building from there and just sort of roughly mark up where I think we might need to introduce some movement joints. So going clockwise from there to this corner here, that looks like it's probably within 6 meters. So I won't need to introduce a movement joint there. Looking at the next section of brickwork into this corner here, well, that looks like it is probably a short return. So less than the 675. So I think what I will try and do is introduce a movement joint within that internal angle there. And again, hopefully we won't read that as anything hugely different from our normal bonded corner that we have on the other side. And then moving to this long section of brickwork here, clearly all of that together looks like it's going to be longer than 12 meters, but actually we've got a bit of a recess here for the opening. So actually check the elevation, see does that recess, does that run the full height? In which case maybe we can use that as a bit of a natural break in the brickwork to introduce some movement joints. So the first thing would be just to determine whether this section here, if that is the case, is within 6 meters. If it is, then fine, we don't need a movement joint in that area. If it isn't, then maybe we do. We've got the recess here. Actually, let's check that. Is that less than 675? If it is, then maybe we need a movement joint. If it isn't, then we won't. And then the next section, again, that looks like it's going to be longer than 6 meters. So from this corner, I'm going to need to do something. And maybe I could have a movement joint sort of at either end of this panel, and then this panel would be within the 12-meter spacing because it's a straight run of brickwork. Actually, it looks like there's a rainwater pipe in this corner here, so maybe I can hide my movement joint behind that rainwater pipe. A lot of people like to do that, and it is quite an effective solution, but actually we just need to make sure that the bracket which is fixing that rainwater pipe has an allowance for movement, so it can slide with the brickwork on one side. Moving around the corner, that looks like it's probably within 6 meters. We'll just check that to see whether it counts as a short return. Moving within this corner, and then we have a very long section of brickwork here, and it looks like we probably have a short return there. So I think what I want to do is debond that short return from the longer panels of brickwork, and then actually we're back to 12 meters from this corner. It looks like there's a couple of rainwater pipes in there, so actually maybe what we'll do is put a movement joint in there behind that rainwater pipe. making sure that the bracket is correct. And then if we need another one here, it looks like we could put one there, and then hopefully sort of this dimension here is within the 12 meters. This next panel looks okay, and then we just check whether this section here is within 6 meters. There's a couple of rainwater pipes in there, so actually maybe we can put one in here. Going round the top of that plan there, everything looks like it's within 6 meters, and then we've got this long section down this final side, whereas actually we have some rainwater pipes in there, so maybe we just hide them in behind those rainwater pipes. There's nothing down towards this bottom section, so maybe we need to introduce a movement joint in the middle of this panel here. If the brickwork is continuous above the windows, or maybe you could introduce something within the window if we have a natural break there. Again, it gets a bit more complex if we have lintels spanning that movement joint, and it's probably outside of the scope of what we can cover in this introduction. So I think the key thing with that exercise, key takeaway, is that actually it's perfectly possible to design something, to build something at this scale. This is Dujardin Mews by Karakusevic, Carson architects. And actually, with a little bit of thought to how the brickwork steps in and out, and the elevations and the setting out in plan, we can hide movement joints where we do need them within those sort of internal angles. And actually, you can have something at this scale of sort of traditional terraced housing without really having any in-your-face movement joints. Even where we're at a magnitude larger than that, sort of moving on to, this is Robert Brown in Primary School by Haverstock Architects. Actually, where the scale is slightly bigger, still by being quite clever with step-in brickwork, we can have a scenario where we're hiding any requirement for movement joints within internal angles, and then actually sort of it's only small sections like this, maybe here, I think you can see another one there, that actually you have the requirement for slightly more visible movement joints. And I know it's not really something you want to be thinking about as designers, sort of at the concept stage, at the beginning process of designing your building, but actually just some clever setting out there to brickwork dimensions can really sort of minimize the need for any overtly in your face movement joints. Vertical movement is subject to the same limitations as horizontal movement. Where a building is 12 meters or lower, around 4 stories, you generally won't require any allowance for vertical movements, so horizontal movement joints. Where a building is going taller than 12 meters, the rule of thumb is really to introduce a masonry support angle at a maximum of every 2 stories. That will allow you to keep the spacing between masonry support angles to around 8 meters or less, which means that your bed joint width for the movement joint can be kept around 10 millimeters. That's the same then for your movement joint and your normal bed joint. You color match the mastic, you have that continuous horizontal movement joint, and again you just don't really read it as anything different from your normal bed joints, your mortared bed joint. So in terms of a detail, this is what it usually looks like. You can see the masonry support angle in there with the sort of the second part fixed there. You can see the pistol brick sitting on top of that masonry support angle, and then underneath that masonry support angle you have your compressible filler, you have your mastic on the outside there, and this, when this brickwork is wanting to expand upwards, you have that movement joint to allow for the compression of that joint. Just a couple of photos of what that looks like in practice. You can see on the image on the left sort of quite a complex detail with clearly some stepping masonry, some stepping support angles there. This image on the right, there's a few issues with mortar being dropped into the cavity, and that cavity tray should sort of extend for the full width of the bed joint. but you can see that masonry support angle in there underneath. You can see the pistol brick sitting on top of that masonry support angle. And the reason for having a pistol brick in that scenario is just to make it a little bit easier for the bricklayer to make sure that they've got that allowance for the movement joints sitting underneath. So moving on from movement joints to a bit more of the detail. The most important bit of the detail, and credit to Ancon for this image, is the wall ties tying the two leaves of the structure together. Whether that inner leaf is block work, concrete block, steel, timber, just making sure that you have those two leaves tied together, making sure that you're sort of following the maximum recommended spacings there horizontally and vertically, which normally leaves you with that sort of classic diamond pattern for the staggered wall ties. Making sure that you have the increased tie density around any of the openings, whether that's a door or a window, or indeed sort of at the edge of a panel, because you have a movement joint there. And just showing you that the maximum recommended spacing from your movement joint should be 225, which is a full brick and stretcher bond to make sure you increase the tie density there. Bed joint reinforcement is something that we get asked about occasionally. You know, many architects, they just want to, even where they are over the recommended spacings, they would just like to omit movement joints altogether. You know, and we often talk about things like using lime mortar, using bed joint reinforcement to see whether it is possible to omit movement joints altogether. And I think it is possible to extend the spacing of the movement joints from 12 meters with bed joint reinforcement, but it is quite a complex analysis and does need sort of detailed consultation with a structural engineer, or preferably with the manufacturers of the bed joint reinforcement if you are going outside of the guidance to standards, just to make sure that you're not going to have any issues there. But also maybe where you have something like very large openings, maybe you have openings which don't stack when they go up the building, maybe you have changes in height, changes in thickness, anything where you might be getting those tensile stresses building up in the brickwork. Just the introduction of some bed joint reinforcement in those areas can get you over any of those particular issues. And you can see from this this project, actually you've got these openings which are offset going up the building, and actually sort of the loads within that brickwork, you're then sort of forcing them on a slightly convoluted path down like this, and you have the potential for some tensile forces building up there. So just the introduction of some bed joint reinforcement within these areas can just make sure that you're covered in terms of that and prevent any unsightly cracking from developing in those areas. There's a couple of different types of bed joint reinforcement. The image on the top there from Ancon, which is probably the sort of the more classic stainless steel ladder type reinforcement, and then the image underneath from Beckart, which is a slightly different product. It's obviously a finer wire, comes in a roll, you can chop it with snips, but they both serve the same purpose of just introducing some tensile strength into the masonry so that the masonry could deal with those forces. So that was a very quick introduction to designing for movement in brickwork. Obviously just an introduction, so if you have anything very detailed, please do make sure that that is checked with a structural engineer, or indeed reach out to the brick manufacturers, always very willing to help with project specific queries. Feel free to get in contact with us if there's anything we can do to help, but thank you for watching.